Okay, so in this video, I'll be showing us how to use first principle to derive the first 5 questions we have on board. Very, very simple. I'll be showing you very easy steps. So number 1, I'll show you in the first step now. Let's take number 1. Number 1, it says, number 1 is y is equal to what? 3x plus what? Plus 6. We should derive this using first principle. Step 1, now look at, there are 4 steps, 4 basic steps we should apply. Step 1, form the equation. We are forming the equation. Form the equation. Now, how do we form the equation? We said the first one, this is the first equation. We have that our y is equals to what? 3x plus 6 is our derivative. Let's call this our equation 1. Right? Our equation 2, we will now substitute y for what? Y plus delta y, as well as what? X, or what? X plus delta x. What this means as a condition is that wherever we see y or x, we substitute with y plus delta y. So now we have this y here, so we substitute y for y plus delta y is equal to what? 3. We are seeing x here now, so we're following this order. 3 brackets, instead of x, we put x plus what? X plus delta x. Then we have plus 6. See, this one is forming our equation 2. So what next now? Step 2, so we subtract, right? We subtract. Step 2 is to say our equation 2 minus our equation 1. That's the step 2 now. How did that go? This is equation 2 minus equation 1. That's y plus dy minus this. So we'll come and say y plus delta y minus y is equal to this one minus this. 3 bracket x plus delta x plus 6. That's our equation 2. I'm trying to bracket them now so I can separate them. Minus our equation 1, which is what? 3x plus 6. I want to show you something. Whatever we are doing with this equation 2, right? Look at everything here must cancel out with something that is here. We are going to be, it's a secret I'm showing you now. This is just common knowledge. If we try and expand this bracket, we must make sure to show that we are in the right frame, because it's subtracting this from this now. Are you seeing? This is our equation 2, this is our equation 1. This is our equation 2, this is our equation 1. Everything must cancel out. Everything from equation 1 must cancel out. I'll show you now. Listen now. Look at now. From here we have y minus y. They are cancelling out. Y minus y is good. I'm left with what? I'm left with delta y here. It's equal to 3 times x. I'm using this one to open just this bracket. 3 times x is giving me 3x, right? Plus what? 3 times delta x. 3 times x is 3. 3 times delta x is what? 3 delta x. We have a plus 6 here, plus 6. Are you seeing? This for the first one. Now what about for here? Minus to open the bracket, right? Minus times plus is minus, so we have minus 3x. Minus times plus is what? Minus 6. It must cancel out. Watch, see what I'm telling you. Look at plus 3s is here, minus 3s is here. They must cancel out. They must cancel out. Let's call this our number 1 that's cancelling out. Number 1 cancelling out. What else now? The remaining one here is minus. Look at plus 6. Minus 6, they must cancel out. That's our number 2 that I cancel out. Are you seeing now? What is left? What we're left with is now our delta y is equal to what? 3 delta x. Nothing else. Are you seeing? What's step 3 now? Step 3 is to what? Divide both sides by what? By delta x. So I can form the slope dy over dx, like I told you. So how do we divide both sides now? We now have delta y over delta x is equal to what? 3 delta x over delta x. Look at there's delta x here, there's delta x, so they will cancel out. Right? So that we're now left with what? We're left with our delta y over delta x is equals to what? It's now equal to 3 as our slope. But that's not all. We're looking for the derivative. And when we say derivative, what do we mean? Find the derivative is what the question asks us to find. Derivative means dy over dx, right? And we know that derivative dy over dx is forming a condition. This will only happen if we limit what? Our delta x towards 0. What this means, if we see anywhere we see dx from here, we should make it 0. Are you getting it now? That's our step 4. This is our step 4. We invoke the condition. Step 4. That's the final step. Step 4 is the conditions. Right? Condition for derivative. This will only happen if we have limits. Are you seeing us? So it's going to be dy over dx is equals to limit of what? Delta x to 0 for what? For this dy over delta x. And what is delta y over delta x? It's equals to 3. And there's nothing like the delta x here. So there's no this one will not apply. What I mean, if you look at this one, there's no delta x that's cancelled out here from here, left with 3. Are you seeing? Therefore, our dy over dx is simply what? 3. Simply 3. That's all. Therefore, our derivative is 3 because there's no dx that will limit to 0. Are you getting it now? So you see how we went through the first step. In step 1 is to form the equation. This one being our first equation, and then the second equation is a condition we are given. Whenever we see y, we put delta y. When we see x is 3s. We've changed it now plus 6. And then step 2 is to subtract. And I told you, I haven't subtracted. Everything we have here must cancel out. If you do it well, minus opens the bracket, and we use this one to open this bracket. If you see, look at what we did now. Everything just can. If you follow the video, you see that it cancelled out. For time's sake, step 3 is to what? You will not divide both sides by. This all 4 steps must be followed. To understand everything we're doing here, you must follow this 4 step. Having followed this 4 step, you see that we'll get everything we want to do correctly. In the next video, I'll be showing you how to do question 2 now. I'll show you question 2 and then we'll proceed from there. Follow me for the next class, guys. Thank you. Now, guys, what I want to show you in question 2 is very strategic. It will help you. I want to show you what binomial expansion is. Without binomial expansion, you cannot solve all of these questions that has to do with what? Has to do with squares and 3 and 4s, all these polynomials and these quadratic functions, right? I want to show you what binomial expansion is. If you are asked to expand x plus y raised to power 2, in our normal term, we're taught that it is going to be what? X plus y, because it is 2, they will multiply themselves. X plus what? X plus what? X plus y. And then this bracket will multiply this bracket. This time this is becoming x squared. This time this is becoming xy. Y plus y times x is the same thing as xy, or y is the same. Plus what? Y times y becoming y squared. Right? And then it becomes x squared plus what? Xy plus xy. That is 2xy plus what? Y squared. What if I tell you there's an easy way of solving this? Or let me expand your memory on how this is being solved. Right? So look at this, what we call binomial expansion. Binomial expansion as regard to what? To Pascal's triangle. Are you getting it now? So how do we expand this using binomial expansion? I'll show you one way. Now look at, in expanding this, let's apply the Pascal triangle method now. Pascal's triangle method states that in Pascal's triangle, this is 1. We start with 1. The reason why we're starting on 1 because any number raised to power of 0 is 1. And you get, so at this point, let's call this point power. And let's call this point the result. Right? Anything raised to power 0 is 1. Right? And anything, and from here, I haven't started with 1, we will not come down and say 1 and 1. It's still constant value. Why? Because anything raised to power 1 is a constant. Right? Haven't done that. What we do now, look at now, from here we start building. We start with 1. 1 plus 1 is 2. We end with 1. Are you getting it now? We start with 1. 1 plus 2 is 3. 2 plus 1 is 3. We end with 1. You see the triangle is forming now. We start with 1. 1 plus 3 is 4. 3 plus 3 is 6. At the middle, 1 plus 3 is 4. We end with 1. What does all of this mean? It means that anything you are expanding that is raised to power 2, the constant must be this. This must be the constant. Are you getting it now? If the power is raised to power 3, this must be the constant. If the power is raised to power 4, this must be the constant. Are you getting it now? So look at now, we are seeing 1 raised to power 2. Which do we use now? If it is raised to power 2, we know that our constant must be this. This must be our constant. So how do we apply this? Look at now. I'll show you in simple steps. Number 1, look at now. If we want to expand this using Pascal's triangle, we start with 1 because we have 1 as our constant, right? And then this one we carry the highest power, x raised to power 2. This one we carry the lowest power, which is 0, y raised to power 0. Then we'll go to plus what? What's the next constant? 2. This one, as this one is reducing, this one is increasing. X raised to power 1, it reduced to 1 because it's 2. This one will from 0 increase to 1, right? Y raised to power 1. Are you seeing? Plus what now? What's the next constant? 1. And then what? What do we have? X will reduce to what? 0. I'm sorry, let me take this one off. Right? So x will reduce to 0 and y will increase to 2. Are you seeing? It's very simple. It's the same thing what we just did here now. When we said x squared plus 2xy plus y squared. I'm just using Pascal's triangle to explain how we can do it easier. Right? 1 is a constant, so we can leave it there. Anything raised to power 0 is 1. So 1 times 1 is 1, right? So we can be left. Okay, let's just continue. We have 1 x squared. Any number raised to power 0 is 1. So 1 times 1 is 1. It's still gone, right? 1 can be an invisible value. 1 times 1 is 1. We're still left with x squared here, right? Plus 2. X raised to power 1 is something as x. Y raised to power 1 is something as y. Are you seeing? X raised to power 0 is 1. 1 times 1 is 1. So it's a constant value. So we have plus what? Y raised to power 2. If you compare this, now, if you compare this with this, you see we have the same answer. I'm showing you this because this is what will bridge us. This is what will help us to solve questions like this. Are you seeing? Let me try and expand. Let's put 4 here and see what we'll get. Let's try and expand using 4. That's we're using 4. We'll be using this. Right? So let's expand, putting 4 here without going through that long process. Let's just go straight to what we have, guys.